Our presenters today are Brandon Tessier, Sales Director, Intelligent Transportation, and Manuel Ochoa, VP Engineering. Brandon has worked in sales leadership roles in transportation for the past decade, with a focus on emerging technologies to improve operations and maintenance for state and municipal agencies, as well as enhancing the overall experience for the traveling public. He is the acting president of the New England Intelligent Transportation Society. Manuel holds an undergraduate degree in physics, an MBA from the Simon School at the University of Rochester, and a master's in electrical engineering from RIT. His experience includes a variety of roles in engineering and leadership from GE, Motorola, and Alstom. Brandon?
Thank you, Lisa. Thank you for everybody who's joining us today. The title of this webinar is Private Network Design, Deployment, and Implementation for ITS applications, but it's also going to serve as a little bit of a primer on what Council Rock is doing in the transportation space, what our goals are, why we think our product and service offerings are really well suited for transportation, and some of our goals in the coming year for transportation, including encouraging more agencies to adopt private network design. We see a lot of transportation agencies that are using fiber or using wireless equipment that's being used on the public carrier networks. But as we see more and more connectivity in the transportation space, whether it be through smart city applications where transportation plays a role in that, or through vehicle to infrastructure and other applications like that, we see a need for agencies to start considering private network as big data becomes more and more forefront, and there's a need to have more reliable network connectivity and to be able to have network connectivity in places where it wasn't previously. So a little bit on who Council Rock is. For those of you who don't know much about us, we're a designer of industrial IoT solutions based out of New York. Why we're well suited for transportation is really the full suite of products and services that we offer. We manufacture our own hardware. We have a software engineering team and are developing software for a variety of different markets, including transportation, and really partnering up with some great third-party software designers and software companies to have software specifically suited for transportation. But we also have a really robust engineering team, electrical, mechanical, engineering design capabilities, and then the ability to install that equipment and then actually go out and maintain it as well. So that real full suite of offerings is really well suited towards transportation. And it all starts with the TELEG, which is our intelligent edge device. We have a couple of different varieties of that. We started with our flagship offering, the TELEG E1500. And we're actually expanding that to a couple of different models coming out in 2022 that are specifically designed for transportation and other applications. We have an E125 and an E155 series that are coming out with a few modifications to them, a little bit better processing capability, storage capability to really run software out at the edge and be able to offer some of that within the transportation space. And then I touched on the software piece. So, we're developing our own Vista device management and data engine software. And we also have some of those transportation specific software offerings that we're working on that we'll get into a little bit of detail here as we work through this webinar here today. On top of that, we manufacture our own cabinets, outdoor cabinets to house all of this equipment in. And that comes with a full design, mechanical design capability to really build cabinets custom to whatever the application in need is, and be able to incorporate full electrical design into that and do a full rapid deployment cabinet that has all of the equipment installed in it and can be rapidly deployed out into the field. And then kind of pulling everything together are our services, which, as I've touched on, from full mechanical and electrical design to RF design and propagation, field surveys. We have a full a field crew that can go out, troubleshoot, install, and then design, install the systems that are designed, and then maintain those systems once we actually get them out into the field. So we'll be talking a little bit today again about why we think private networks are well designed for the ITS space, and then we're going to get into some specifics on more of these services and products and what their ITS applications are. One of the things that sets the TELEG apart from other wireless routers that are out there is really the edge computing when we talk about the transportation space. So the ability to run software right out at the edge, whether it be software that is used for traffic signal control and allowing an agency to get eyes on a traffic signal corridor, and be able to control those traffic signals, reset those traffic signals, change schedules, to be able to do that all out on the edge, as well as doing analytics for incident detection, traffic counts, and wrong way detection. So those are some of the different applications here that we can run right at the edge. And all of this is done, with a future-proof path to 5G. We're very aware of the demand for 5G, and we're prepared for that. And we have a path to that with all of the devices that we are manufacturing to date. One of those use cases for ITS that we're using the Telig for right now is a project that we've had in Prince George County, Maryland, where Prince George County required some traffic preemption technology to allow emergency vehicles preemptive pass-through at critical intersections. The need that Prince George County had was to run that software right out at the edge. So Council Rock implemented the Telig 1500 with that software run right out there at the edge, which allowed us to really minimize the impact of any type of network outage. So that software is running whether or not we have access to the network or not. A little bit lower latency by running it right out there at the edge. And then, the software is capable of doing more than just preemption, direct signal override, status confirmation, really a whole host of things that software can do on top of just the preemption and prioritization piece. Is already built right onto the Telig and is there for Prince George County to use as they continue to advance and have different needs. So let's dive a little bit into, private networks for ITS and, what our approach is specifically for intelligent transportation systems and why we're looking at, trying to educate the sector on more utilization of private networks. I think traditionally, you see a lot of the, traditional connectivity options in this environment. A lot of states have existing fiber networks, but those don't get out to reach everywhere. So they might have a fiber ring installed, and then we're talking about more rural areas or just gaps just outside of that fiber ring that need to be filled. This is where LTE, CBRS, and then 5G really comes in and provides a lot of options. And certainly the global trend is towards private wireless networks. There's a massive amount of investment in R&D right now into private LTE and 5G, and it's a highly secure way of transmitting all of this data. There's a huge economies of scale, and it really enhances the edge computing capabilities that we have and provides a pathway for a more long-term evolution by using this technology. Some of the traditional private network drivers that we see apply to the intelligent transportation space is to increase the reliability of the connectivity. As we talk about more connected devices, this becomes more and more critical that our communications networks are running, and private networks just provide a higher level of reliability than you can with some other options. It also allows some of these agencies to better control their costs. We're talking in transportation, there's a lot of video surveillance that's done to detect incidents and do traffic counts and just have eyes on different parts of the roadways. But there's a great amount of cost that comes with that if you're moving all of this data over just traditional public carriers with their data plans and taking on that cost on a month-to-month basis as you deploy more and more devices. So as we see more and more cameras, more and more detectors out there on the roadways, how are agencies going to manage, this cost month to month and year to year as that continues to grow? And then how are they going to fill gaps in network coverage? By deploying a private network and doing it wirelessly, this allows them to more quickly build out that infrastructure, even in a rural application, and especially in a rural application. The Telig is designed to be a low power consumption device, so it can be easily run off of solar and used in more rural applications where there may not be other connectivity options, and it's just not feasible to run fiber. And then the flexibility that comes with deploying, your own network, a truly private network, and the ability to upgrade your technology year over year and replace, legacy equipment so that you can take advantage of the increased bandwidth and lower latencies that are coming out with, developments in private network technology. And we certainly see this, as I said, this is being adopted globally. Take a look at just the growth and the outlook for private LTE and 5G as we see, continuous advancement in connectivity and increased demand for automation. These networks are filling that need, and the ability to accommodate machine-to-machine learning, and also to address concerns over how congested the networks are as more and more devices are put on the networks, and we see more and more demand on those networks. There's concern over, am I going to be able to have the reliability that I need through my connectivity, and am I going to get the quality of service that I need? How are we going to address those things? Well, private LTE and private 5G networks are filling that need. So again, some applications for intelligent transportation systems is to help manage some of those costs for high data devices such as CCTV and video surveillance, to be able to run analytics, get remote access, and then even in areas where there is existing fiber networks, how are we backing up those networks? As anybody that relies on a fiber network knows, all it takes is somebody taking out, there being an incident on the highway that takes out a junction box where the fiber is being run, and all of a sudden you've lost connectivity to your network. Well, wireless is a great backup to have that, especially in critical applications, so that you have a little bit more increased reliability. And then there's some increased security here that comes into play as well. And Manuel, who's on the call here today, we'll get into that in just a moment. Actually, so, Manuel, why don't I turn it over to you here, and you can get into a little bit more detail on the differentiators between, what is these traditional private commercial networks versus a true private network, and then get into some of the exact examples of private networks that we're considering deploying.
Yeah, thank you, Brandon. So as Brandon was saying, so just talk a little bit about some of the key differences between a private commercial network and a private network. So the main differentiator is the ownership of the network. And with the ownership comes, what can you do to a network to meet your service level agreements? When you have a private commercial network, I think the most important factor is what are your SLAs? What are the service level agreements that you sign up with the provider? And then you are just another customer in the queue when something goes wrong, and you're using the infrastructure as well that everybody else that has a cell phone will be using. There is an operational expense, so every month you will have to provide it's a cost of ownership, and it's every month depending on the agreements you have. The data that you use is going to be part of that all the time. Like I said, it's that network is shared among all the users on that network, commercial, industrial, and for personal use. So that's part of that network. So quality of service and any other mission critical applications you may have, somehow they could be impacted by the use of this network. Prioritization of traffic, I mentioned, mission critical applications require low latency, and they need to be sent regardless of what other traffic is going on that network. And sometimes it's a little bit challenging to accomplish that as well in a private commercial network. And then reliability. So the traffic that goes into a private commercial network, it goes to the cloud. You have your own tunnel, secure tunnel to get to your facilities, but it still has to go to the cloud. And all of that time takes from the end device to your applications. It has to traverse that network, and sometimes latency may have an issue, or the reliability or consistency for the packets to arrive on time as expected as well. In a private network, you build a network to meet all of these requirements. You have latency requirements, you build the network to meet those latency requirements. You own the network, you operate the network, and you set your own SLA expectations to operate that network. You will have to, if you don't have a team that can operate and manage these telecom networks, you will have to build a team that is going to help you do that, or you can partner with somebody like Council Rock to help you operate and manage these networks. You will own the spectrum, or you will have access, free access to a spectrum available to use these networks. And then you can move some of the operational expense that you will have in a private commercial network out of the operation. You will have some capex. You will have to invest in the infrastructure when you build this network, but your operational expenses will be reduced. And you have control of how much you can reduce those expenses. It is going to be a network. You will have full control of security, authentication, who is in the network, how is the network connected, how is the traffic flowing in the network, and more important is for those mission critical applications, you will have control of deterministic expectations of traffic going from those devices to your applications. So that's some of the key differentiators between those two networks. They both refer to as private, but one of them is where you have total ownership of the data and the infrastructure that is transporting that data as well. The architecture for an LTE, a private LTE network. If you already may have a radio SCADA network and you're familiar with that architecture, the main concept of a private network, a private radio network, is you have a remote radio and you have a base station. Those are the two most common components for a standard radio network. For a private network like LTE, so you have the same two components. The remote radio in LTE lingo is referred to as UE. It stands for user equipment. Also refers to as CPE, customer premise equipment. CPE is mostly referred to situations where you have fixed applications, and I'll talk a little bit about that. So it's the same component as a typical SCADA network. Then you have the base station. In LTE, the base station is referred to as the radio access network, and there is only one component in that network is for the base station. It's referred to as, it's called the eNodeB, or Evolved Node Base Station. So that will be the component for the base station. So in addition to these two components, there is a very key component for an LTE network, which is called the EPC, or Evolved Packet Core. This is a piece of software that communicates between the outside world or your enterprise network. You can connect to other networks like the internet, but also is the interface between all the other two components of the network. There are specific interfaces for that, but it has all of the information about base station or eNodeBs and the end devices. And more is not showing on this drawing, but as part of the LTE core, there are few components that make this deployment more secure and easier to operate and manage. One is called the HSS, which is basically the home subscriber server. And this is the component in the LTE network where you basically register all of the subscribers that have access to this network. Not only subscribers that have access, but what type of access they have, these subscribers. Are they allowed to go to another network? Are they allowed to, how much bandwidth of the network they can use? You can even set up the QoS policies that they will use in the network. You can apply all of that in this module, the HSS. And then there are two more general components of the core. One is the MME. And basically the MME is the entity that controls all of the high-level operations between the end users and the eNodeBs. So make sure that the connections are alive, make sure that they hand over if you're using mobility and you're roaming, they take care of all of that. It will take care of all of that high-level signaling between those two modules. And then the other component is what's called the gateway. There are two components for that. One is the SGW, which is the serving gateway, and the other one is the PGW, which is basically the packet data network gateway, the one that takes you to other networks or the outside world. And you can control on these two components Like I said, what are the other networks that you're interfacing to? What are the, you can connect other base stations or InnoDBs in between to allow for roaming purposes, for example. So that's the high level network. And then at the end, in the end, all of that interfaces to your existing backhaul infrastructure or enterprise infrastructure, where you have all of your backend applications such as back office, SCADA, security, or device management. So that's a typical private LTE network, and you will see how we can help you not only to deploy these networks, but with the different components that I mentioned, we have a way to provide that technology as well. So we talk about private LTE networks. Private LTE means you own the infrastructure, but as part of the infrastructure for a network, a radio network, is the spectrum. In private LTE, there are a few options to deploy a private network. One of them is what's referred to as CBRS, which is space of the spectrum. It's 150 megahertz of spectrum in the 3.5 gigahertz band. I will talk a little bit more about these. And there are a few other options. You have options to operate at 900 megahertz, and you will have to, there are some, these are not of free access. You will have to get into agreements, lease agreements, or buy some of the spectrum. And then there is other options in 2.3 gigahertz as well, where you will have to do the same thing. You will have to get some sort of agreements to get access to this spectrum. But going back to CBRS, this is very, it's a good way to deploy a private LTE network because it's available to everybody. Actually, you don't have to apply for a license to use the spectrum. All you have to do is to use an FCC certified device that operates in this band, in the CBRS. And our products, they all are CBRS, and they all are FCC certified to operate in this spectrum. There are 3 levels of using the spectrum. Depending on where you're deploying these networks, you will find more of the incumbent. Incumbent is this spectrum has been reallocated as of late last year to be used in a way that is going to operate more efficiently by the implementation of software to eliminate and mitigate any potential interference problems. But there's still the incumbents, and those incumbents, most of them will be, they are located on the coast of United States, so on the East Coast and on the West Coast. But everywhere in between, there are just a few exceptions where there are some incumbents, but everything else is of free access. And then you have 2 other tiers of access. One is the what is called the general authorized access, and for that individuals or enterprises or organizations that use the spectrum as a GAA, a general access, all you have to do is, like I said, you use a certified product, and then you just go and use the spectrum. You have to use, it's called SAS, which is spectrum access, to allow you to select what frequencies you're allowed to use, but you're free to use the spectrum. And then if you want to have access to more spectrum and you don't want the SAS to be changing your frequencies all the time because you're really running into a very mission critical applications, you can also do priority access. Priority access, the rule is you can buy a portion of the spectrum. It's a bidding system with the FCC. There was recently a bid process that happened this last summer, and that's another option. You can have blocks of frequency in different locations that will give you priority of use of the spectrum in those locations. So that's a little bit of CBRS, and like I said, it's like the ISM 900 megahertz spectrum. You just get a radio that operates in CBRS that is FCC certified, and you can start operating in that environment. Next slide. So I talk about the architecture. I talk about one spectrum that can be used. There are deployment considerations that probably is important to discuss as well, such as I mentioned the spectrum. Are we going to buy it? Are we going to list it? Are we just going to operate in CBRS? FCC paperwork, depending on what spectrum you're using, you have to go through FCC to make sure that you comply with the rules. Also, there is FCC requirements for if you need to build a new tower communication. There are some forms, there are some permits, there is a process that you have to follow with the FCC to do some of this work. And then is the RF design. What can I get with the spectrum? With the RF design, is going to tell you, okay, how much infrastructure will I need to deploy to get all of this coverage? These are my requirements. I need to get this much coverage. This is where my end devices will be located. So an RF design is going to give you information about where are the base stations. Can you reuse some of the base station locations you already may have for SCADA applications or other type of telecommunications? Or will you need additional space to deploy these tower structures or whatever the telecom structure will be to help you provide the service coverage you're looking for? So with all of these questions and the manpower, how am I deploy these? What type of people or what type of resources will I need to go and deploy these assets? Are the CPEs or UEs are fixed deployments, or are they going to be moving from location to location? What type of deployment is going to be this? And you need to be able to implement this. You may have the resources internally to do this, or identify who can help you build these networks. And then oops, just go back a little bit, Brandon. Just like everything else, there is a learning curve. It's new technology. If you're going to operate and manage this network, how I'm going to get my teams trained and capable of running this network. So that's a little bit of the questions that probably everybody wants to ask if they have little or no experience deploying private networks. And that's where we come into your help as well. So we will talk a little bit about our solution, not only as the technology provider for the telecommunications, but also as an organization that can help you deploy these networks. And we can help you in many different ways. So the engineering work that I mentioned, we can help you with all of the engineering or most of the engineering for telecom that you will need to do in order to prepare for a deployment of these networks. Network design, security and RF design, how is the traffic going to flow? What are the priorities I need to have? How is that going to interface or integrate into my existing enterprise network? RF design, how many assets will I need to deploy to make sure that I have the service that I'm looking for? And all the other components, engineering that you will need to do, like building construction standards for your installation, if these are base stations or these are CPEs, providing you with electrical and mechanical design and drawings for those standards. Equipment integration, are they going to interface to microwave communications, to SCADA communications, to fiber? How do we get all of that integrated? As well as power systems. Do you need additional power system? What type of power systems you require to add these private radios into your network? Or backup systems in the event of a power outage? What do you want your systems to operate? All of that information, all of that engineering work, we can help you with that. Once you have the engineering, the next logical step, can we go to the next slide, Brandon? It's how do we validate that this engineering design is going to work? So we can help you with site surveys. We can help you with validation of the technology, validation of the service coverage you're looking for by doing drive testing or collecting data by setting up some temporary base stations to make sure that then we can go and collect data, compare that to the RF models and make sure that the predictions and the engineering, one is to validate it and if it's, and also to optimize it. So we have the field teams that can help you do that, and field engineers that can help you collect and gather all of this data, just to make sure that all of the engineering work that you have done is validated. And that is always the case for a wireless network. As you know, wireless communications is not, it is science, but it's not exact science because there are so many factors that change the behavior of signal propagation. And that's why it's important always to at least do site surveys and validate some of this preliminary design work. And then the next part is, okay, so now I know what I need, I know how to build, I know what I need to build, I have the technology, I know what I need to do. How do we build all of this? And we have experienced teams that can help you with that, not only with the implementation of these networks, we can help you with project management, we can help you with the actual work, installation work, and we can help you setting up your teams to maintain and operate these networks after the network is being deployed. So we can train your teams. We can help you build your teams that will have the skill sets and the roles to manage this type of networks. Or we can even help you with the operation and maintenance of these networks as well. So we have a full feature of a full set of features that we can help you in accordance to your needs, your current teams, so that you can be successful deploying and operating and maintaining this network for the long term. So I mentioned these: installation, testing, maintenance. So we can help you with that. I think the most important part is the training. So it's new technology, and if you don't have a private LTE network today, there are few different components that you have probably not been engaged with, and we can help you with that. So we will give you the training, we will provide you with the training, and we will get your teams up to speed so that they can be successful with the operation of these networks and the implementation of these networks as well. And then just to say something, we are a very safety conscious company. So everything we do, we follow all the national codes, local codes, and safety is first. So we make sure that all our crews are keep safety in mind all the time. We don't have any records of any safety or any bad safety records in the history of the organization. We will provide our safety policies are always our own internal safety policies, but also follow our customers' policies, and we will do whatever is the most strict at for any activity. So we will always make sure that we are using we're implementing the best practices that is going to keep our employees, going to keep our customers, going to keep our users in a safe environment. So with this, I turn it back to you, Brandon.
Okay, yeah, great. Thank you, Manuel, for that overview there. And, really we focus kind of on CBRS today because as we look at transportation, and we were talking before about a lot of those data costs, I think CBRS is a great consideration within the transportation space, especially with the tele's ability to have full radio failover. If you're an agency that wants to really try to save on data costs and use CBRS, but you're a little concerned over what kind of reliability you're going to get through just the general access level that CBRS provides with no data charges, there's always the ability to have multiple radios within the tele and be able to fail over if you're not getting connectivity through CBRS to one of the public carriers. And in that case, you're on an a la carte data plan where you're only using data through the carriers if you're not able to communicate over CBRS. While we in some of the deployments that we've done on a limited basis, we haven't seen any issues with that, but we understand that it could be a concern. CBRS, so far it's a new technology, but it's been very reliable through all the different access levels. But for some of these critical applications where connectivity is a must, there's that ability to have that failover so that you can take advantage of the free data outside of maintaining and installing the system. There's that cost, but outside of that, access to that free data with failover to one of the public carriers if for any reason you can't connect via CBRS. So one of the things that we offer is a CBRS starter kit. This is a great way for any agency to kind of just kick the tires on CBRS. It's very quickly installed. It comes with this airspeed unit, which is the eNode B that he was referring to when he went over Manuel was referring to when he went over the system architecture, which comes with an integrated antenna. And then we, as part of the starter kit, there's 4 telegs that come with a full accessory kit with the and their own antennas and power supplies, et cetera, et cetera. And then, the full setup support and then connectivity to the SAS. So again, everything through CBRS. Any request for pushing data over the network has to be approved through the SAS. That's the one fee that does come with CBRS. It's very, very minimal. But we provide that SAS connectivity so that any client that's looking to kind of kick the tires on CBRS can do it with this CBRS starter kit. A few points on this teleg, which is the core of our product offering, industrial grade with the powerful edge computing to be able to utilize that automation right out at the edge. So another way to control data and data flow, if you can perform analytics right out at the edge, video analytics right at the edge, there's no need to push all of that video data back over the network. So even in applications where an agency is still tied into a public carrier and paying for data, if they can perform those analytics right out at the edge, there's an ability to control some of those costs and get a little bit more reliability if network connectivity is lost. I mentioned the multiple failover options, the radio for moving from CBRS to one of the public carriers, but then also from a reliability standpoint, failover on the network. So, you can have a dual SIMs, AT&T and Verizon SIMs in this unit. And if you're ever having issues pushing data over one of those two carriers, you can fail over to another carrier by having dual SIMs within the unit. And then I mentioned the lower power consumption, which is ideal for trying to install this device in a rural or solar application. There are other companies out there that are providing some of the edge computing that I've been touching on, in hardware that they've got right out at the edge. But I think one of the other key things here, especially as we look at space, if anybody's opened a traffic cabinet and tried to wedge a new piece of hardware in there, sometimes it can be really challenging. The small form factor that we have here by combining everything into this one small box is much different than what a lot of others are doing with the hardware that they have that's maybe able to run traffic signal control or run an ATMS out at the edge. Typically, you're seeing a much larger device that's taking up a large space in the rack, whereas ours is in a much smaller form factor. I mentioned kind of the forward-looking technology, the pathway to 5G, all of this built right into the Teleg, so you don't have to worry as we start to make the move to 5G. And then, Manuel mentioned some of the other spectrum that's available, 900 megahertz. And these are some things out of traditional carrier LTE spectrum that is also available all through the Teleg. We support all the global 3GPP, including CAT-M, NB-IoT. So you have some other options there if you're looking to deploy outside of private network and use some of these different spectrum that you might have access to. I mentioned the multiple radio capable. So, mix and match LTE from CBRS to narrowband to band 8, band 48, a lot of different capabilities here, all built into this single box that we have here with the Teleg. And then just a quick look at some of our certifications. We're certified with Verizon and AT&T. We're currently working through certification with T-Mobile. We're certified on FirstNet, CBRS, and you can see some of our other certifications, fully UL, FCC certified, IEEE, and there are data sheets available on our website that can kind of go through all of this if you're looking to do a little bit of a deeper dive into the different certifications, the environmental hardening that we have for each one of these devices. That's available on our data sheets. We mentioned enclosure design and build. So just another quick look at that and everything that we can kind of build into these rapid deployment cabinets. You can see that the quick product overview sheet there that shows a fully deployed, ready to deploy cabinet with all of the components installed. We provide a full set of mechanical and electrical diagrams that come with this for submittal packages, can provide battery backup built right directly into the cabinet. So all of this available through our rapid deployment cabinet and enclosure design and build capabilities that we have. The last thing I wanted to kind of mention to everyone here on the call is some of the stuff that we're doing with software. So we've been partnering with ThruGreen on developing software specific for the ITS space. I touched on that at the beginning of this webinar with the Preemption pilot project that we're doing with Prince George County in Maryland. Right now, the software in its current development stage can do a lot of different things. Intersection health services, from being able to connect legacy traffic hardware. So we're able to connect to traffic signal controllers and other legacy equipment where agencies may not have had connectivity to that before, and then be able to directly control them. We're doing all of that right now through NTCIP, but we're working on even being able to connect to some of those devices that aren't even running NTCIP and just using some traditional local programming through serial that right now require on-site command and control to be able to change schedules and some other things like that. We can take a look at a traffic intersection and provide some analytics and be able to alert you on different anomalies, sync it to a clock, and be able to have any devices tied in to our device and into the software, all synced and now running on the same clock. To be able to upload different signal timing plans and adjust that as you do different agencies do different studies and need to make adjustments to their signal timing plans. And then also through the AI built in to the machine to be able to take a look at the data that we're receiving and dynamically make adjustments to the signal timing plans that are already in place. Where we have an app that's able to run on different smartphones and be able to pick up on that in different vehicles and be able to share that data so that we can help get a gauge on congestion through any type of corridor and be able to better manage our signal timing through that, as well as any kind of onboard devices that are already communicating from the vehicles. And then to be able to relay any of that information that we have to other intersections and traffic signal controllers at those intersections that weren't previously connected. We can now do this wirely so that if you have a series of intersections and there's several of them that don't have the ability to detect what's going on with traffic congestion in that area, we can take the data that we're receiving at an intersection upstream or downstream and then pass that along so that now that intersection is a little smarter, and we can actually build a smart corridor by linking these together wirelessly and using the software that we have. And then I mentioned the prioritization services, and this again touches on the work that we've done in Prince George County in Maryland, and that's priority for transit, for buses or trolleys or whatever other kind of transit vehicle might be trying to move through a corridor, government fleets, and emergency vehicles as well. And this is just a quick look at what that dashboard looks like, kind of on a very brief overview. It shows you now, you see the green dot, it's populated on a Google map. It shows you the status of the cabinet, that we've got power. You see the UPS power there. We're not running, we're working off of AC power and not running on the UPS. It'll show you that location, and then it'll actually show you what the signals are doing at that particular intersection, and give you the ability to control that in real time, and also give you a full view of what your battery and power systems are doing, and give you alerts and notifications via email or text should there be any kind of anomaly in the system or anything else that you've built into the software that you want to have alerted to you. You can see one of those alerts there that we're seeing that in this particular intersection is running on UPS. Utility power is off. So now if we need to roll a crew out there to figure out why we've lost power before we lose our battery backup through whatever autonomy is provided on the UPS system, an agency is able to do that. That's a brief look at some of the software things that we're doing specific to transportation, and a real need here for municipalities that are trying to operate, hundreds or thousands of traffic intersections and traditionally haven't been able to get eyes on everything. By using the Telelink, we provide communication where there wasn't communication before, and then we provide software built onto that can give you all of these different analytics and control and command features. And again, that's all built into one box. And that's whether or not you're running a private network or a public network or running a hybrid or whatever it is. This all performs either way running on that device.
Thank you to Brandon and Manuel for presenting today's topic, and thank you guys for attending. If you have any more questions you can think of, please email them to btessier or lholmes@councilrock.com, and then be sure to visit councilrock.com for more information.